Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals cosine of x on the interval pi over 3 included to 5 pi over 3 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to apply. The first condition, the function f of x, which is cosine of x, has to be continuous on the closed interval given. Well, the cosine of x is continuous everywhere. It's therefore continuous on any interval, including on the closed interval of pi over 3 to 5 pi over 3. Closed means that it includes both endpoints, indicated by the square brackets on both endpoints. Condition 1 is met. The second condition, the derivative, f prime of x, which the derivative of cosine of x is negative sine of x. The derivative has to be continuous. It's called differentiable on the open interval. Well, sine of x, just like cosine of x, is continuous everywhere, and therefore negative sine of x will also be continuous everywhere. So it will be continuous on any interval, including the open interval, so we can say it's continuous. It's called differentiable for the continuity of the derivative on the open interval. Open means it does not include the endpoints, indicated by the round brackets on both endpoints, because a function is never differentiable on its endpoints. So these are always going to be not included and be the open interval. Condition 2 holds true. The third condition, the function evaluated at the left endpoint, A, has to match the function evaluated at the right endpoint, B. In this problem, we have the interval of pi over 3 to 5 pi over 3. The left endpoint A is pi over 3. The right endpoint B is 5 pi over 3. So we need to evaluate f at the left endpoint, pi over 3, and f at the right endpoint, 5 pi over 3, and see if they're the same. And these are evaluated by plugging them into the function cosine of x. So f of pi over 3 is the cosine of pi over 3. The cosine of pi over 3 is 1/2. F of 5 pi over 3 is the cosine of 5 pi over 3, which is in the fourth quadrant of the unit circle. And in the fourth quadrant, cosine is once again positive, and this is the pi over 3 equivalent in the fourth quadrant, so it's once again a positive 1/2. So we do have that f of the left endpoint, pi over 3, does match f of the right endpoint, 5 pi over 3. So condition 3 is also met. All three conditions are met. Rolle's theorem does apply. Rolle's theorem says the slope of the tangent line, the derivative, evaluated at c, will equal to, from the mean value theorem, the slope of the secant line connecting the endpoints, f of b minus f of a over b minus a. But in Rolle's theorem, we have the third condition holding true, f of a equals f of b, so if you subtract them, it equals to 0. Rolle's theorem is the special case of the mean value theorem where f prime of c, the slope of the tangent line at c, equals to 0. Where c is in the open interval. We are guaranteed there will be at least one c, maybe more c values in that interval. We will now go and find those c values. The left side, f prime of c, is evaluated by plugging c into f prime of x. That will give negative sine of c. And that's equal to 0. We can divide both sides by a negative 1, so sine of c will equal to 0. So we need to think of all locations where the sine of c is equal to 0. And we want to keep those that end up in this interval of pi over 3 to 5 pi over 3 on the unit circle. To assign a c to be a 0, c can be a whole bunch of things, including any integer multiple of pi, like negative 3 pi and negative 2 pi and negative pi and 0 and pi and 2 pi and 3 pi and so on. It can be any of those values. Dot, dot, dot. But we want to keep only those that are in this interval of pi over 3 to 5 pi over 3. Pi over 3 is bigger than 0, which means anything that's 0 or less will not be included, so we don't want any of these ones over here. And 5 pi over 3 is not quite as big as 2 pi, because 2 pi is 6 pi over 3. So none of these are included over here either. It looks like we're left with just one c value, that pi right there. We were guaranteed there would be at least one. There may have been more. In this case, there was only one value. So it looks like c equals pi is the value of c that satisfies the conclusion of Rolle's theorem for this function.